to you. But this is the one that I didn't finish earlier, so I'm going to do it. So if you were here Friday, that's the one that we were doing Friday. That's those problems. So I suggested you do the y-intercept first. You just have to break it all down, get all the pieces. Okay. For the y-intercept, x is always 0, always, always. So all I have to do is plug in a 0 into every x. So that would look like this. 2, put a 0 here, put a 0 there. And then that's just a 3. Put a 0 here, put a 0 there. And all those things, they just cancel. Okay, and the only reason I'm writing them is just so you can see, but you could probably figure that out, that zeros just go away. And all I'm left with is 3 over 12, which I believe that's 0.25, but can somebody check that for me? 3 divided by 12, please. It's 0.25? Yeah. So x, again, x is always 0, always. And then this is, bless you, 0.25. There's the first piece of the puzzle. They didn't ask me for y-intercept, but they should have, because it's part of the graph. Okay? So here it is. Yes. Okay, the next part, like on Friday, like I told you, the next part I suggest you do is your HA and your OA. And so based on this, both of the powers, the degrees, they're both 2's. Okay, so if they're both 2's, that's a Betsy problem, right? So this is a Betsy problem. Betsy, okay. And the reason it's a Betsy problem is because of the 2's. They're both 2's, which this stands for equal, right? Equal. And so that means that my HA is going to be equal, y equal, the leading constants. So the two numbers in the front. So if I go back over here, that's a 2 and that's a 1. So 2 over 1. Right, that's your equation. So this will be y equals to 2 over 1, which is really just 2. So here's my HA. Y equals 2. And if I have a HA, automatically you know that you will not have a OA. Right? Now, please do stop me, okay, if anything doesn't make sense. Those of you that are kind of working with me, we good? Everything good so far? Any questions, guys? Okay. That brings me to the third part of this problem, which is this side, right, the factoring. Can somebody that's working with me tell me the problem again so I don't have to scroll up? It's a 2, right? Yeah, 2x
squared minus 7x plus 3 over x squared minus 7x plus 12.
Thank you. And so the third part is factoring, okay? Which I'll put it over here, guys, in a box, that because it's really important that you factor first. You can't get none of that information if you don't factor first, okay? And this is the part that I'm a little nervous for you guys, because like if you don't do all the practices and you didn't do, and you get to this problem, we haven't factored one of these in a while, and so you might forget. I could see students forgetting that you're supposed to multiply those two to factor this problem, right? And so you do 2 times 3 is 6. And think of what number times what number multiplies to 6, but adds to -7, right? And so in this case, it'd be -6 and -1. But when you have a 2 in the front like this, we do the 2 fractions. Oops. Like that. And then one of the 2 fractions reduces. So in this case, that one reduces to that. And so my top factor is x minus 3 to x minus 1. That's what I'm nervous about. Like if you guys forget how to factor that, because we just haven't factored those a lot recently. The bottom, yeah, go ahead.
Do you just simplify with the 1 and 3?
Yeah, the 2 and the, you just shrink it down, you just reduce. Yeah, so what I really did is divided by 2. Yes, ma'am. Good question. And then the bottom one, x minus 4, x minus 3. right? Because negative times the negative is a positive, and those two add up to -4. But anyways, there's both of them factored. From here, you just do this. The ones that cancel are your whole. And so we do have two that cancel right there. So that's my whole. At least that's the x of the whole. So not -3, but +3. Because it's the opposite, right, when you solve that. And then to get the y of the whole, so this is the whole y, you have to plug in the 3 back into the leftover. So this is what I have left over. And so I plug a 3 back into both of those x's. And what would that be? 6 minus 1 is 5. And that's -1, so -5. There's my whole. Good. And then the bottom one that doesn't cancel, that's your vertical asymptote. So I have a vertical asymptote at x equals 4. So vertical asymptote at x equals 4. And the top one that doesn't cancel, that's your x-intercept. So this is my x-intercept. Does anybody have a question so far? Those of you that are with me? No? Okay. So my x-intercept, I'm going to show you the work for that. So x-intercept comes from 2x minus 1, I believe. Is that right? Yeah, 2x minus 1. So if I set that equal to 0 and I solve it, I get x equals 1/2. So there's my x-intercept. So 0.50. Remember, for the x-intercept, the y will always be 0. Just like for the y-intercept, the x is always 0. Okay. I have everything I need. I'm just going to do the domain now. So my domain will be from -infinity to +infinity. And then you just jump over the x of the whole and the vertical asymptote. So I need to go find out what those were. So the whole is 3 and the vertical asymptote is 4. So I need to jump over 3. And then I need to jump over 4. Okay. So again, 3 was the whole. So this is the x of the whole. And that's your vertical asymptote. It always jumps over the whole and the vertical asymptote because those are your discontinuities. Any questions, guys? So the x of the whole is the 3, and then the vertical asymptote was 4. And your domain rate, and this is a very important question, yes. The domain's always going to jump over those. Always. And they don't have to be in that order. It doesn't have to be VA and then whole. It could be whole and then VA. Or it could be 2 VAs. Okay, 2 vertical asymptotes. Anybody else question? Okay, beefy problem, beefy problem. Okay, so now I just graph all this information. And your test will have a graph. Okay, so you do have to know how to graph these. 1, 2, 3, 4, 5, 6. It's really easy, honestly, to graph these. Can somebody that's with me tell me what the VA is so that I don't have to scroll up? Okay, so at 4, right here, thank you. We have this. So there's a VA at x equals 4. Then we have a HA too, right? What's it? 2? Y equals 2. So right here I have a HA at y equals 2. We also have an x-intercept. Well, what was the x-intercept? So 0.5. And then we also had a y-intercept. Is it 0.25? Was that the 0.25 one? For the y-intercept? Yeah, 0.25. And then we also had a hole at -3, or I don't know. What was it, guys? -3, -5? -3. I don't sound right. Oh, okay, that one sounds right. Yeah, no, you're good. I was like, that doesn't match my graph. Okay, there it is. Okay. So, okay, if you don't know how to graph, just watch these 5 seconds. Okay. Once you put the information there, all you have to think about, well, how can I connect these dots? What's the only way I can connect these dots? I know it has to touch this one, it has to touch that one, and it has to touch that one. That's the only possible way you could touch those 3 dots. Okay. And remember, these always have symmetry. So how could this one have symmetry? Yeah, it has to. That's the only way. That's the only way. Okay. Any questions on that one, guys? If you can wrap your head around this problem, that's like the main idea of this whole Unit 2B. Okay. Okay.